Our next video today will be about empirical and molecular compounds. So here we're going to look at what it means to have the percent composition of a compound, and the other one is about the molecular formula of a compound. So let's see if we can answer this question today. The first question we have is, what is the percent composition of a compound? So if you have a percent composition, so we have a definition here, is the percent by mass of each of the element of that compound. So let's see. If it happens that I have 1 mole of iron, then it is 100% iron. That is easy. On the other hand, if I have 1 mole of here sodium bicarbonate, here we have several type of atoms in the formula. So that means that the mass of sodium is a fraction, a percentage of the whole mass of a mole of sodium bicarbonate. And here you can see that if we have hydrogen, we have a very small percentage of mass of hydrogen compared to the whole mass of this formula here. And that's what we're going to look into today. In order to do this work, we're going to have to know that if I have 1 mole of sodium bicarbonate, I need to know what is the molar mass of this compound, and I also need to know the molar mass of each of the individual compounds, for which I will compare to the overall mass of the compound. So let's see if I can get some data from the periodic table. After a visit to the periodic table, I figured out that 1 mole of sodium is 22.99 grams, 1 mole of hydrogen is 1.008 grams, a mole of carbon is 12.011 gram, and 1 mole of oxygen is 15.999 gram. Now the question here is, I need to know the total mass of 1 mole of this sodium bicarbonate. So let's see if I can do some calculation here. I know that in this mole here, I have 1 mole of sodium at 22.99 grams per mole. I'm going to also add the mass here of 1 mole of hydrogen, 0.84 per mole. I'm going to add here the carbon, which is 12.011 gram per mole. And I'm going to also add the oxygen. But interestingly enough, there are 3 atoms of oxygen. So here what I have to do, I need to add 3 times 15.999 grams like this per mole. So in order to know what is the molar mass of this sodium bicarbonate mole, I need to figure out, okay, I need to add these numbers together. So let's see if I can take my calculator to do so. So I'm going to start with the multiplication. So I have 3 times 15.99 plus 12.001 plus 1.008 plus 22.99, and that gives me 83.996 gram. So that's an important information, because now we have the molar mass of this molecule. So let's see. 1 mole of sodium bicarbonate is 83.996 gram like this. That's important. This information is very important for the next step. You'll see. So remember that what we're looking for is the percent composition. So I want to know the percent by mass of each element of that compound. So let's see. So if I have here the percent composition of sodium, I will have here the molar mass of sodium, which is 22.99 grams, divided by the molar mass of that same compound, 83.996 gram. So here, when I find my calculation, I have 22.99 divided by 83.996. Cool. And because it's a percentage, I'm going to multiply by 100. And this gives me 27.4%. So this is the percentage composition of sodium in sodium bicarbonate. So let's see if I can write the equations for the other elements, and then we'll chat in a moment. So let's see what I just calculated. We did the percent composition of sodium. Now, if I do the percent composition of hydrogen with a molar mass of 1.008 grams, knowing that 1 mole of sodium bicarbonate is 83.996 grams, and then I do the division times 100, I can see that hydrogen, being such a small atom, would have such a small percent composition in the compound. With respect to the percent composition of here carbon, I have your molar mass of carbon over the molar mass of sodium bicarbonate, and here times 100 gives me 14.3%. Now here for the percent composition of oxygen, I have to keep in mind that I have 3 atoms of oxygen. So that means that when I have the molar mass here of oxygen, I need to multiply this by 3, which gives me 997 grams, and then I divide by the molar mass of sodium bicarbonate. So here I multiply by 100, I end up with 57.1%. Now I haven't done the check. Let's see if we can add to about 100 or at 100%. So here I'm looking for the total percentage for this for each of these atoms with respect to the compound. So 4 plus 2, 6, plus 3, 9, and 1. So here I have 0.0. So I have 27 plus 1, 28, 29, 33, plus 1 is 43, plus 57, I end up with 100%. So when I'm looking for percent composition, I was able to figure out for the sodium bicarbonate all the calculation that I needed. Indeed, if it happens that you want me to do another example or a few more, put the comments, the questions in the comment below, and I'll be more than happy to answer these questions for you. At this point, I'm just doing the lessons, hoping that if you need help, you will ask for help. So let's see if I can look at the next part, which is what does it mean, an empirical formula? So let's have a look. So earlier on this video, we talked about, let's see, I just forgot the word, we've talked about percent composition. Now, percent composition gives you the percentage of each of the elements in the compound. So that means that you can, through the same process, figure out how many grams you have for each of the atom in the molecule. So here, when I talk about the empirical formula, I'm giving you a mass, the mass you have of each of the elements, and you're trying to figure out what is that molecule that contains these ratios. So here's something to keep in mind. To get the empirical data, given the mass of each of the element of each compound, you need to find the compound formula. So here the example I have is that, first of all, you can always, when you do your calculation, refer to 100 grams of compound. So here I have that for the sulfur in that new compound, I have 40.05 grams of sulfur. That means that I have 40.05% of sulfur, and I have 59.95 grams of oxygen, or I could say I have 59.95% of oxygen. See, given that you have 100 grams of compound, you can transfer the percentage right away into grams. Now, the idea here is that we need to know what is the compound that we have in this example. So here, let's see at the information we have on the periodic table. So first of all, we know that we have 40.05 grams of sulfur, but we also know that for each mole of sulfur, we have 32.07 grams of sulfur, and that is on the periodic table. We also know that for 59.95 grams of oxygen that we have in the compound, we also know that each mole of oxygen contains 15.999 grams of oxygen. So here, by elimination, we have gram of oxygen, gram of oxygen, gram of sulfur, gram of sulfur. So here I'll be able to know how many mole of each of these elements I have. So let's do the calculation. I'll get my calculator. So let's see. So my calculator, I will do 40.05 divided by 32.07. And here I have 1.25 and 25, why not? 25 mole of sulfur here. The next one here, I'm going to take this number. I have 59.95 divided by 15.999, and that gives me, I'm going to round it off to 3.75 mole of oxygen. So here we've got the number of moles of each of these elements given the percentage we had and also the grams of each of those elements in the compound. So here we need to figure out how many moles of each we have. So here the trick is, given that we have two numbers here, we want to know the ratios of each of those atoms in the molecule. The trick is you look at the smallest answer and you use this one as a reference. So let's see what it looks like. So I have here 1.25 mole of sulfur, and you divide by the same thing, 1.25, and that gives me 1. Okay, that's good news. The next one here, I have 3.75 mole of oxygen divided by the same number, 1.25. 3.75 divided by 1.25 gives me 3. So here what do we have? We have 1 mole of sulfur, and here we have 3 mole of oxygen. So the big question is, if I have a mole of a substance, and in that substance we have 1 mole of sulfur, and we have 3 moles of oxygen, that means that we were able, oops, that's number 2, it's a 3 because I have 3 moles here, SO3. That means that I was able to figure out the composition of that compound given the percentage of each, the percentage in grams of each of the elements inside that compound. And here, this is a simple one with 2 different elements. We could do the same with many more, and that's interesting this way. So that is interesting. I learned that today as I was looking into it. It's a new word for me. If you have enjoyed this video so far, don't forget to subscribe to this channel. I'm putting new videos as I go along every week. This is helping the student I tutor. This is answering their questions. And indeed, once you look at these videos, if you have clarification questions or if you have a question you'd like me to answer, put them in the comments below. On this, I'm happy to help you. I'm going to lead you to another video here where we're going to learn a bit more about chemistry, and my database of video is growing, and you'll see it is quite nice. On this, have an excellent evening, and I'll see you in the next video.